program is called Xray Diffraction. Which another name for it is called Xray Diffraction. It's really actually pretty cool. In X-ray diffraction, it's similar to thin film. You have an emitter that's emitting X-rays towards some sample of material. So whatever material you want to learn more about. Well, due to the law of reflection, there will always be some light reflected back, and it reflects back at the same angle that it came in at. Law of reflection. Over here you have a detector that's measuring how much light is actually reflecting back and hitting the detector. In an X-ray diffraction machine, you can move this emitter. So you can change the angle that it's hitting the surface at. What's happening is some of the X-rays are reflecting off the top surface, but some of the X-rays are passing through and hitting off the next surface of atoms and coming out. So materials are made of a whole bunch of atoms bound together. So we have all these atoms in here. So some of the X-rays reflect off some of the atoms that are on the top surface. Some of the X-rays pass through to the next surface of atoms and reflect off. Similar to thin film interference, depending upon what this distance is, one wave's going to travel farther than the other. If that second wave travels a whole multiple of a wavelength, we're going to get constructive interference. The detector would read a lot of X-rays coming back in, because they would be constructively interfering. To take the angle into account, we end up with the cosine theta term in there. The extra distance depends upon the cosine of theta. D is the distance from one level of atoms to the next level of atoms. So what you do if you're using an X-ray diffraction machine, you're sitting up here and you're moving the emitter really slowly, and you're watching the detector. As you move the emitter, you're going to get really high readings on the detector. As you keep moving, the readings are going to get low, and then they're going to get high again, and they're going to get low again, they're going to get high again. So you're going to pass through periods of positions of constructive and destructive interference. If you know the positions, meaning the angle that the emitter's at, then when you see constructive interference, you know theta. Wavelength you know the wavelength of the X-rays that are being emitted, you'll be able to find D. You'll be able to find the distance between the atoms. So material scientists use this a lot to figure out the structure of the material they've made, or the material they're working with. So it's really a pretty interesting little application of interference.
So this could tell us density of material.
It could. It can tell you what type of bonding it has. Like you have your face center cubic and that sort of thing. It can tell you that.
Use it for like mineral analysis at the they have a Xray diffraction machine. So.
Yeah.
Yeah, mining assayers use this.
Very cool.